Children, let us start the new chapter, Areas of Parallelograms and Triangles. Before that, let us discuss about the plane figures, congruent figures, and also about the areas of congruent figures. You know that parallelogram is a plane figure, triangle is also plane figures. Then what is planar region? The part of the plane enclosed by a simple closed figure is called a planar region. Part of the plane enclosed by a simple closed figure. The magnitude or measure of the planar region is called its area. And this magnitude or measure is always expressed with the help of the number, that is 2 centimeter square, 5 centimeter square, 10 meter square, hectares, etc. These are the magnitude of the planar region, and the magnitude or measure of the planar region is called the area. So we can say that area of figures is a number associated with the part of the plane enclosed by the figure. And also you are familiar with the concept of congruent figures. Congruent figures. So when two figures are said to be congruent, two figures are called congruent if they have the same shape and same size. See, these two figures, they are congruent figure. Congruent figures are having same shape and same size. Two figures are congruent if they have the same shape and the same size. Then what are the properties of congruent figures? Congruent figures are having same shape and same size. If the congruent figures are placed one upon the other, they coincide with each other. If you keep one triangular shape on the other triangular shape which are congruent, they superimpose each other and they coincide with each other. They superimpose or coincide with each other. And next, congruent figures are having equal areas. Area of congruent figures are equal. And here same shape means they must have the shape of triangles, or they must have the shape of quadrilateral. That is the shape. And size means their corresponding parts must be equal here. If they placed one upon the other, they superimpose means they coincide with each other. And also they are having equal areas. These are the special properties of congruent figures. We can superimpose one figure over the other such that it will cover the other completely. So consider if A and B are congruent, the figure A and figure B are congruent, they must have equal areas. Here these two are having equal areas. But two figures having equal areas need not be congruent. Congruent figures are having equal areas, but the figures which are having equal areas may not be congruent, need not be congruent. Consider this figure. The area of this rectangle is 2 into 8 equals 16 centimeter square. Here length is 8 centimeter, breadth is 2 centimeter. So the area is 16 centimeter square. Consider this figure is also having the area 16 centimeter square, 4 into 4. Are they congruent? They are not having same shape and same size. So even though they are having equal areas, they are not congruent figures. Therefore, you can say that the figures which are congruent, they are equal in area. But the figures which are having equal area need not be congruent. Also you know the formula to find the area of the plane figures. The area of the rectangle, area of the square, area of the parallelogram, area of the triangle. So what is the formula to find the area of the triangle? That is A is equals to half into base into altitude. That is A equals half into B into H, where B is the base and H is the altitude. And area of the square, area of the square is equals to side into side. If A is the side, then A equals A into A, area equals A into A, that equals A square. So you can write A square, A is equals to A square. And what is the formula to find the area of the rectangle? Area of the rectangle equals length into breadth. That is A equals L into B, where L is the length, B is the breadth. And then what is the formula to find the area of the parallelogram? That is area of the parallelogram equals base into altitude. That is A equals B into H, where B is the base and H is the altitude. In this chapter, let us consolidate the knowledge about these formulae by studying some relationship between the areas of these geometric figures under the conditions which they lie on the same base and between the same parallels. This study will also be useful in the understanding of some results on similarity of triangles. Now let us observe the figures which are on the same base and between the same parallels. See the figures here. In this figure, ABCD is a trapezium and BCEF is a parallelogram. ABCD is a trapezium, BCEF is a parallelogram. They are on the same base DC. They are having the common side DC. And here also observe the parallelogram PQRS and MNRS. Parallelogram PQRS and MNRS are on the same base SR. They are having the same side, common side SR. So these are the figures which are on the same base. Trapezium ABCD and parallelogram EFH are on the same base DC. In this figure, parallelogram PQRS and parallelogram MNRS are on the same base SR. Now you come to the next figures. See these figures. Here also two triangles are there. Triangle ABC and triangle DBC. They are having the same base. They are on the same base BC. So the triangle ABC and triangle DBC are on the same base BC in this figure. And observe this figure. Here there is a parallelogram ABCD and a triangle PDC. PDC is a triangle and ABCD is a parallelogram. They are on the same base DC. So the parallelogram ABCD and triangle PDC are on the same base DC. In all the cases you observe that two figures, trapezium and parallelogram, two parallelograms, two triangles, parallelogram and triangle, they are on the same base. Next let us continue. See these figures. Observe the figure here. ABCD is a trapezium and EFCD is a parallelogram. Clearly they are on same base DC. Parallelogram and trapezium. Trapezium ABCD and parallelogram EFCD are on the same base DC. In addition, the vertices A and B of the trapezium ABCD, which is opposite to the side or base DC, and the vertices of the parallelogram E and F, also opposite to DC, are on the line AF parallel to DC. They are on the line AF and that AF is parallel to DC. So what you can conclude here? The trapezium ABCD trapezium ABCD and parallelogram EFCD are on the same base DC, and also they are between the same parallels AF and DC. Observe this figure. In this figure, PQRS is a parallelogram and also MNRS is also parallelogram. Two parallelograms are there, PQRS and MNRS. They are on the same base SR. On the base SR, both parallelogram PQRS and MNRS are there, and observe their vertices. Vertices P and Q of PQRS and vertices M and N of MNRS lie on a line PN. Here PN is a line. The vertices P and Q of a parallelogram PQRS and M and N of the vertices of the parallelogram MNRS are on the same line PN, and that PN is parallel to SR. PN is parallel to SR. Therefore, you can say that the parallelograms are between the same parallels PN parallel to SR. So, these two parallelograms, parallelogram PQRS and parallelogram MNRS, are on the same base SR and they are between the same parallels SR parallel to PN. So, these are the figures on the same base and between the same parallels. So, what do you mean by the figures on the same base and between the same parallels? Two figures are said to be on the same base and between the same parallels if they have a common base or common side. If they have common base and the vertices opposite to the common base of each figure lie on a line parallel to the base. Here, two figures are said to be on the same base and between the same parallels if they have a common base and the vertices opposite to the common base of each figure lie on a line parallel to base. Then they are said to be the figures on the same base and between the same parallels. See, here also triangles are there. Triangle ABC and triangle DBC lie on the same base BC and between the same parallels AD parallel to BC. So, these are the two triangles which are on the same base and between the same parallels. Here also you observe parallelogram ABCD is there and triangle PDC is there. Parallelogram ABCD and triangle PCD are on the same base DC and between the same parallels APDC. So, these two are the figures on the same base and between the same parallels. Here also two triangles which are on the same base and between the same parallels. So, here you write two figures are said to be on the same base and between the same parallels if they have a common base or common side and the vertices opposite to common base of each figure lie on a line parallel to the base. Keeping in view the above statement, you cannot say that triangle are on the same base and between the same parallels if any one of the vertices not lies on the line parallel to the base. Observe here, in all these four cases, in all these four situations, the figures are on the same base and between the same parallels, as they are on the same base and the vertices opposite to the base are they are on the line parallel to the base. The vertices of both the figures are on the same line which is parallel to the base. But you consider these two. Here the triangle PQR and triangle DQR are on the same line QR. But here the vertices P and D are not on the same line which is parallel to QR. Here this line is parallel to QR. Only one vertex is on the line, but D is not on that line. So you can't say that these two are the figures on the same base and between the same parallels. And also you cannot say that parallelogram EFGH and MNGH lie between the same parallels EF and HG. Now let us come to the exercise 1. See the question here. Which of the following figures lie on the same base and between the same parallels? Same base and between the same parallels. In such a case, write the common base and the two parallels. Here first we have to recognize the figures which are on the same base and between the same parallels. After that, if they are on the same base and between the same parallels, we have to write their common base and two parallels between which they lie. So see the first figure here. Here what you can observe, the figures are trapezium ABCD and triangle PDC. Yes, you can observe that they are on the same base. They are on the same base DC and between the parallels AB parallel to DC. Second figure, they are not the figures on the same base and between the same parallels. Yes, they are on the same base, yes sir, but they are not between the same parallels. So here these figures not comes under the figures on the same base and between the same parallels. Next, you take the third one. What is the third one? There is a parallelogram PQRS and triangle TQR. You know that they are on the same side QR and between the parallel PS parallel to QR. So you can say that triangle QTR and parallelogram PQRS are on the same base and between the same parallels. And in this figure, triangle PRQ and parallelogram ABCD, they are between the same parallels, but they are not on the same base. Here PQ is the base of the triangle PRQ and BC is the base of the parallelogram ABCD. Now you take this figure. In this figure, APQD is a parallelogram and ABCD is a parallelogram. They are on the same base. They are on the same base AD and between the same parallels BQ and AD. So you can say that they are the figures on the same base and between the same parallels. In this figure, figures are not on the same base and between the same parallels. So you write the answer. Here, this is the figure 1. So you write, in this figure, triangle PDC and trapezium ABCD lies on the same base DC and between the same parallel lines and between the same parallel lines AB and DC. AB and DC. The second figure, here in this figure the figures are not between the same parallels. Not between the same parallels. Then here you take in this figure here same base is there, that is RQ. For QR you take triangle QTR or TRQ. Triangle TRQ and parallelogram and PQRS on the same base RQ, on the same base RQ and between the same parallels and between the same parallels RQ and SP. RQ and SP. Next, in this figure figures are not on the same base. Not on the same base. Next, in this figure quadrilateral APCD, you can have the quadrilateral, and ABQD also you can take, or otherwise quadrilateral APQD and ABCD also you can take. In this figure quadrilateral APCD and quadrilateral ABQD lies on the same base. Lies on the same base AD and between the same parallel lines AD and BQ. AD and BQ. In this figure figures are not on the same base.